Scientists have been searching for new ways to study outer space and the universe. In 2021, the James Webb Space Telescope was launched into space, and what was discovered will blow your mind and shake your belief system. Join us in this mind-opening video, and let's get shocked.
Audio Jungle.
The James Webb Space Telescope, or JWST, is a space telescope used for infrared astronomy. NASA engineers developed and designed it alongside the Canadian and European space agencies. As you can imagine, it is the biggest optical telescope in space, weighing 12,000 pounds. It was officially launched on the 25th of December 2021. With its high resolution, the telescope is used to study the physical universe beyond the Earth's atmosphere, including observations of exoplanets and the formation of galaxies. Over the years, the JWST will release myriads of snapshots of the universe, providing more details about the world we live in. On the 11th of July 2022, the first snapshots taken by the JWST were released. The image showed the deepest view of the universe, and the image released caused panic among cosmologists observing the content of the snapshot. After its release, multiple astronomy reports revealed that various galaxies were spotted in the image. These galaxies were described as surprisingly smooth, small, and too old. These galaxies also raised confusion among cosmologists as they began to contemplate the widely accepted theory about the creation of the universe, the Big Bang Theory. According to scientists, the universe started with multiple specks of energy packed into a single point. The single point expanded with unrealistic force, creating everything in the universe and still developing. In the expanding universe, a strange optical illusion always comes into play, as galaxies or other objects cannot continue to look smaller with increasing distance. At a certain point, they should start looking larger because their light is supposed to have left them as they get closer to us. However, JWST shows galaxies smaller in size, even galaxies with the greatest luminosity and mass than our Milky Way galaxy appear to be 2 to 3 times smaller than in similar images observed with the Hubble Space Telescope. Nonetheless, the galaxies shown by JWST are about the same size as those near us. It is assumed that the universe isn't expanding, and redshift is proportional to distance. According to the Big Bang expanding universe hypothesis, the distance galaxies must be highly tiny to compensate for the hypothesized optical illusion, meaning that they are further out than they appear, which means that they are older than the Big Bang. As nothing could have existed before the Big Bang, these galaxies demonstrate that there may be confusion if the big hit even occurred. Nevertheless, it is the first observation by cosmologists since the launch of JWST. The first year of the statement of Webb's observation time is known as Cycle 1. Observation time on the JWST is assigned yearly and is grouped into 3 parts. The first part is the director's discretionary time, and the second is the guaranteed time set aside for scientists who helped build the JWST. The third part is usually referred to as the Cycle 1 General Observers Programs, which entails scientists writing and submitting proposals to the TAC, Telescope Allocation Committee, explaining why they should be granted the observation time with the JWST and the benefits that it would bring to the field and subfields of astronomy. Up to 250 days were allocated to observing programs to use the JWST. The approved proposals for Cycle 1 were released in May 2021, including the Cosmos Webb program. The Cosmos Webb program will use 2,086 observing hours to survey 500,000 galaxies with multi-band, high-resolution near-infrared imaging and a unique 32,000 galaxies in mid-infrared. The data will be quickly released to the public for other researchers to use the program. It also aims to search for fully evolved galaxies at high redshifts to understand their rapid evolution better and challenge existing models of universe formation. The JWST is set to broaden our understanding of the universe as cosmologists can analyze the oldest galaxies, shedding new light on how multiple galaxies assemble over billions of years with its high-definition infrared sensitivity. Galaxies are essential as they show us how matter is organized in the universe. Astronomers have had a lingering interest in understanding the nature and history of our universe. With this in mind, they studied how matter is currently organized and how it changes over time, exploring the subatomic particles that make up matter into the immense structures of galaxies. Every study fills several gaps about the origin and evolution of the universe. The JWST will also allow us to peer back over 135 billion years and witness the formation of the first stars and galaxies. Following the Big Bang, the universe was like a hot soup of particles. But as it cooled down, protons and neutrons began to combine hydrogen and ionized helium atoms. These atoms attracted electrons, creating neutral atoms, allowing light to travel freely for the first time. Nonetheless, the end of the cosmic dark ages is still the first source. It would take time before the first sources of light would form. The JWST is also used to monitor star formation in nebulae. The complex process in which stars are formed is known as a stellar formation. It begins with the collapse of the nebula. It becomes denser and hotter. Eventually, the temperature and pressure become high enough for nuclear fusion and the birth of a new star. During the formation of a star, huge streams of dust particles surround the forming star, which blocks most of the visible light emitted. This process makes it hard for telescopes that observe invisible light to study the early ages of star development. Nevertheless, infrared light has a longer wavelength than visible light. It can penetrate through the dust barrier, meaning the James Webb Space Telescope can observe the formation of stars and the surrounding dust and gas in unprecedented detail. Scientists will also be able to observe the processes that lead to the formation of planetary systems, and these studies will aid in understanding the formation of stars and planets. The James Webb Space Telescope can not only provide a deeper understanding of the universe and our place within it, but it also has the potential to revolutionize the study of exoplanets, or planets that orbit stars outside our solar system. The transit method is one of the main ways the JWST will be used to study exoplanets. The transit method detects exoplanets by looking for the dimming of a star's light as its planet passes between the star and the Earth. When a planet passes in front of a star from our perspective, it blocks a small fraction of the star's light, and scientists can determine the planet's size by measuring blocked light. Despite the popularity of this method, as it has been used to detect thousands of exoplanets to date, the JWST will revolutionize it as the James Webb Space Telescope will be able to see the presence of exoplanets that are much smaller and farther away than those that have been detected using previous methods. Furthermore, the JWST will be able to measure the mass of these planets by using ground-based telescopes in conjunction with the transit method. This will allow scientists to determine the density of the planets and infer their composition. However, the most exciting part of the JWST capabilities is its spectroscopy. Spectroscopy is a technique that allows scientists to study the design of a planet's atmosphere by analyzing the light it reflects or emits. The James Webb Space Telescope will be able to do this for exoplanets, providing scientists with the ability to detect the building blocks of life elsewhere in the universe. Exoplanet research is a relatively new field. The JWST will play a crucial role in advancing our understanding of these distant worlds, bringing us closer to answering whether or not we are alone in the universe. The James Webb Space Telescope will be invaluable for studying the universe and answering fundamental questions about our place in the cosmos. What do you think the JWST will discover over the years? Do you think the current origin of our universe is accurate?